Hello, welcome to today's stream. Quick update on logistics. Adrian might not be able to make it today. There's been some scheduling issues that went under the radar, and it's possible I'll be hosting a solo sesh today. Welcome. Happy afternoon if you're from Europe. Good morning, good evening. Today is the final session of TDD February. Now, that doesn't mean that we won't ever have TDD sessions anymore. What it does mean is that we're now sort of trying to paint a whole picture. We started with the basics, then we went into the more technical side, then we went into the specific technical side with modern problems, most specifically React with Nick Shoemaker. And today we're looking at the business side of things. Now, Adrian did have a few anecdotes prepared, so we'll just have to do another show at some point to go through them. So don't worry, we will continue to have TDD topics in the future. It's just that this sort of exclusive focus on TDD sort of closing today, but I got some exciting news to share. Let's put the banners. Yeah, let's put the banners in. It's going to be awesome. It's been a while since we had a solo stream. How's everybody doing? The risk of February 29th. Yeah, I think, now that it's a leap year, right? So now that you've said that, it's very possible that has something to do with it. I personally sometimes mix up calendars that start with Sundays with calendars that start with Mondays and do that all the time. So it is what it is. Today's topic is about, well, the title was a bit catchphrasy, right? So the title was supposed to get your attention on the main question, is TDD going to help? Is TDD going to boost my team? Is TDD going to build trust with the stakeholders? Is it going to be a friction point? A lot of people seem to be either practicing it, but then there's sort of a limit to how deep it goes, or they're not practicing it. Now, I've surveyed my audience, and my audience predominantly practices it, which is a lovely bias. So you're all ahead of the curve. All of you who are viewing us live today, you're way ahead of the curve. So I would like to commend you and recognize you for that. Today, where should we start? I think we should start with saying hello to our live viewers. Caloran, hello. It's good to see you again. We had a very lovely... where did it fall? Here. We had a very lovely... our tech journey coffee, like after show yesterday, and you all gave us amazing feedback. So what I gathered there is that there's definitely going to be a lot more topics about communication, about conflict management, and about estimations coming in the near future. We're planning to do something of the sort in April. But I'm thinking maybe March is the right. March is now the right stepping stone, since we've mentioned it yesterday, and now we have this sort of opening up, widening of the topic space once more. What else is in the pipeline, you might ask, for the show in general? We are in discussions with Brian Finster to get him onto the show, specifically about platform engineering, and one of the talking points on that will, to some degree, cover AI as well. So how LLMs or AI can be used for platform engineering or CI/CD pipelines or anything in between. So it's still all very experimental, but Brian has some amazing ideas there. So we still haven't discussed in high detail yet, but the enthusiasm is really high. So that's regarding the show. That's going to be at some point in March-ish, April-ish. I do believe we have a date, but I'm not going to say anything. I'm not going to say anything concrete until it's confirmed from all sides. Let's see. All right. What else do we have? We have today's topic. That's all we have. Business side of TDD has always amazed me. I coach teams predominantly on this idea of somebody in the team is excited about TDD, but then they're sort of stuck in this idea of, well, there's constantly pressure from somebody, from management, from marketing, from sales, from senior management. And now if we start adopting TDD, everything will slow down even more. We're already being perceived as these like black sheep, as the engineering department as being very slow or sluggish. And now by adopting TDD or something similar or something adjacent, we'll slow down even further. That's usually the top feedback that I see voiced. I'm sure that's not the main problem, but at least that's the one that's being voiced collectively on LinkedIn. Let me know if you agree. Let me know what your stance on this is. Like how sexy is TDD in your company for your management? You know, from top down. Do they know about it? Is this more like a craft? Is this more like an engineering focus? Is this more individual craft? Is this more craftspeople sort of doing their thing? Do you have some teams that do it, some teams that don't? Do you have some people that do it and some people that don't? I've usually been more in that camp where it wasn't. It's very rare, let's say, for me to have worked in an organization that TDD would be done by default by everybody all the time. Even when I talk to other practitioners like Brian, like Adrian, Nick Shomeko, even they say, yes, I do TDD. I'm a TDD practitioner, but I don't do TDD all the time. I think that's a normal stance to have. And that also matches my experience with how I practice it. So then, of course, the obvious question is, well, if it's that good and you don't do it all the time, like what's the catch? What's the context here? And that's what we're going to discuss today. So we're going to look into a few product side caveats, a few business side ideas about what to measure and what really to focus on, how to communicate this. And we can talk a little bit more about a few announcements that I have to make somewhere sort of halfway through the show. So stay tuned. Let me open up chat. Hello. Chat's loading. Who here had sort of had a difficult conversation with engineering management, with management in general, and open up the idea or present the idea, hey guys, should we do TDD, should we not do TDD? How did that conversation go for you? Or maybe you were interviewing and you got that question as an interview question. Maybe it was a trick question. I'm curious what your situation was. So that's my ask. For those of you who are here live, I see there's quite a few of you. What does that conversation usually look like? What does a conversation look like if you like doing it and somebody's telling you to stop? What does a conversation look like if you're not doing it and somebody's sort of encouraging you to start? What does a conversation look like if there's no rules and you might sometimes do it and sometimes not? Drop it in chat and we'll discuss. Let's start at the beginning. Business, product. So on the business side of things, TDD, from my experience, is complete la la land. It's so technical that it's very unlikely that any non-technical person in the business would show passion or enthusiasm or interest for just the topic itself or the acronym itself or what is really going into the practice, into the discipline. Because generally you have to do it in order to understand it, and it's very hard to explain to somebody for it to make sense, because it emphasizes this abstraction that you need to be able to explain to somebody what design is, what testing is, what behavior is, what the testing plan is, what QA is, what quality is, what is implementation, what are interfaces, what are features, how do the features separate out from code, from deliverables, so it already requires a lot of jargon just to explain to somebody. So I think TDD is usually just a engineering side conversation. Even product people who are not technical, I sometimes struggle with sort of holding a conversation with them sort of level to the same degree as I would with a CTO or a technical product manager, a technical program manager, or a delivery manager. Even DevOps people sometimes do TDD in some way if they're building any kind of scripts or any kind of tooling internally, or platform engineers. I mean, but that's holistic DevOps. That's, you would normally consider those people to be engineers. But the business has a different view on this, and I think our industry would benefit from just having let's say a quick vocabulary check for discussing these kind of things. And I see our efforts like team topologies, Flow, Kent Beck's most recent book, Tidy First, and even his newsletter now about talking more about the economics of software. I see a lot of valiant effort being invested into sort of making these topics a little bit more approachable, and that's our inspiration for today as well. Let's say you're in a situation, this is an example scenario. You're in a situation that requires you to build a lot of features in a given timeline. You have a budget, and you've done this a few times, right? So the team has stayed mostly the same. This is a permanent setup, let's say, inside a company. This is not agency style. This is a company that has in-house development. And let's assume you're not doing TDD. You might be writing some tests. Maybe you have some end-to-end tests and a few complex integration tests. But let's say testing at its core is limited to a few engineers, to a few components, in a few critical areas. And in some areas, it's limited to things that are easy to test rather than important to test. Right? So that's our situation. I see this plenty. Type a 1 in chat if you're in such a situation. I'd be really curious if somebody is actually in that situation right now. That would be a cool coincidence. So the trick here is that if you're not doing any kind of behavior-driven conversation, right? So I'm using BDD technology, BDD terminology here, behavior-driven development, right? So we want to have English conversations, English comments, English documentation, English architecture diagrams that capture the behavior of a system, right? So it doesn't talk about, what's a good example? UML diagrams is a great example. UML diagrams are terrible because they very rarely talk about behavior. UML diagrams, I mean, most kinds of UML diagrams, process diagrams, class diagrams, database, they talk about implementation. They talk about structure, they talk about coupling, they talk about dependencies, but they don't talk about behavior. It's very rare to get, because that's more in the UX side, a UX diagram or pure data flow. And those UML diagrams are extremely rare. So the UX flow would be similar to what you would consider it to be a graphical user journey to be. And on the data flow side, you're in the realm of event modeling. Event modeling, the way that Adam Dimitruk describes it, which is a great way of designing software. But everything in the middle is this constant issue of developers talking way too much implementation to each other. It's like, I need this function, or I need this class, or I need this API to return something. Let's see. Jeff says, some users make good use of Excel tables to describe desired behavior, like for pricing. Yeah, I like that approach. Sometimes I've seen teams work in such a way that they say, okay, accounting has a spreadsheet, and we would like to move the spreadsheet into our system, because right now they're exporting CSVs into the spreadsheet and they're sort of trying to clean it up in case anything's wrong. And usually that process of cleaning up things is what's most important. In this example that I mentioned, right? So that is very easy to miss, right? So whenever a human is doing something, it's their thinking process that you would ideally want to automate. It's the brains behind the keyboard that you would want to sort of capture down on paper. Now, sometimes these Excel spreadsheets, if it's a monthly thing, it's very likely that there are some exceptions that only a human knows how to deal with. And with anything Excel related, usually the output is best served to continue to be Excel, even if it's automated. That would be my suggestion. Build a living prototype. If they're already using Excel as a UI, just automate that merging together the CSV or the export into their Excel. Don't rebuild a UI, because if they've used Excel up until now, then the UI that Excel provides is good enough. Just get the data in without them having to fiddle manually. Of course, if the Excel sheet can cover the scale and the load and perhaps the security requirements or the privacy regulations of your business, like that's the devil's in the details. So generally, the breakdown happens in this communication between teams. You go into a meeting and it's just way too technical. Jeff mentions, many Excel spreadsheets are full of bugs. There's buggy ass programs, but with less testing. Yeah, I mean, it's funny that you should mention testing, right? Because like double bookkeeping accounting is meant to sort of solve that problem, right? Like you have this wet principle being applied, like write everything twice, right? So there should be two versions of the data flow going in opposite directions, so you can then verify independently, or at least to some systematic degree, whether the numbers add up if you take a different route on one of the routes. Now that's not actually testing. That's just having a second. That's just having redundancy within the domain itself. So this idea of credit and debit and which side's in, which side is out, and to whom, and they are all relative, and you can flip them around. So it's this sort of binary take of like a magnet. It has a plus and a minus sign, and I can sort of flip it either way I want, and no matter how many times I flip it around, it still needs to make sense. Like the overall magnetic field outside of the system needs to be consistent, and the things that go out and remain inside need to match what went in, plus taxes, right? So that's the idea. Because when Jeff was on 2 weeks ago for the kata that we did, we finished that example on 99 bottles, writing tests, writing implementation, driving the behavior of the exercise. We ended up with a key problem when we gave the exercise to ChatGPT, which is ChatGPT didn't really differentiate. The kata was so simple that ChatGPT didn't really differentiate the implementation side of the code and the testing side of the code. It looked okay, it looked to work. But both sides of the code were two different implementations of the same problem, and then we just compared it together. Right? Because there was no integration. It's a static problem. It's a black box function. That there's no external state, no external services. So it was obviously a kata meant for deliberate practice. So I don't fault ChatGPT here for getting it wrong, or just sort of oversimplifying the output, the solution, its solution. But it goes to show just how difficult it is to really explain what the difference is between behavior, between implementation, between detail, and between what you would consider requirements, or whether that's requirements gathered through conversation, whether that's requirements gathered through a business analyst or product owner, or extracting requirements by virtue of observing some kind of diagram or architecture spec or designs, or maybe even just having somebody walk you through an app. Hey, we would like to build this, and it's an iPhone app, and it does this, it does that, and then there's this 10 screens, and here's what can happen. And then the engineers sort of reverse engineer it from that, right? So on the business side of things, when it comes to TDD, what's really important is something that John Gallagher recently mentioned on one of his streams. As a podcast guest, he mentioned that if I take my business stakeholders and I sit them down in front of the tests, or I sit them down in front of the implementation for those tests, they should be able to sort of connect the dots. They should be able to look at a test. It's written in plain English. It's hopefully using internal jargon for business concerns. And their guess of what something does should match reality. And usually it doesn't. Usually it's like way off. Usually you have a customer in your database and it's something completely, it's very much, it might not even be a human that has ever purchased something. It might just be login credentials or a mix of login credentials and marketing credentials. And, it's really going into the nitty-gritty details of domain-driven design, which is, did you distill the domain to the degree that you have unique words for each unique concept in the domain, rather than having a user and then you have different instances, partials, types, or an account or a transaction, and then you have different types and exceptions, right? So usually when you have types and exceptions, your main atomic pieces are too granular, right? So it's too specific on what they do. And when they're sort of being connected together into some abstractions, they're mostly infrastructure abstractions. It's like, oh, I have this entity here, and it extends some kind of class from the ORM because we happen to be using the same database as that other unrelated entity. So you sort of connect them together infrastructure side, not domain side. And again, that's a clean architecture concern. It's not really the point of today. Think about a situation where you're in this project. Okay, remember, this team has history. This team is working on features. This team doesn't have very good testing practices. Now the question arises, okay, should we practice TDD? Somebody says, hey, I watched Dennis's stream. Should we just push TDD across the entire organization? How does that happen? Does that even make sense? First of all, for the business, let's say on the senior management side, somebody asks the CTO, hey, we heard these things about continuous delivery and TDD. Does that make sense? And whichever way the conversation goes, there's usually somebody already resistant to this idea. Otherwise, it would have been implemented. The same as microservices. These things are quite fashionable in our industry. They are being recommended by people like me. They're being recommended by recruiters. They're being recommended by bootcamps. So generally, everybody sort of knows a little bit about CI, CD, TDD, DDD, clean architecture, solid principles, even if they don't practice it. They are sort of in the theory or theory adjacent. But it's about the practice, really, for the business that needs to make sense, right? So on paper, if I tell you, okay, from now on, every day, the entire team takes an extra hour to learn TDD or to write tests, what does the business see? Jess Humble had a great example here from, and I'm writing an article on this, and you'll get the article very soon. I will probably post it after the episode. Today's just been a little bit too hectic for me to follow through on that. I just need the numbers here. So it's the Jess Humble. It's the Jess Humble episode from. Let me find it. I need to open Notion. I have my notes. Show notes. Production. There we go. So it's a 2008 study from HP LaserJet's firmware division. So it's It's a quote. It's a case study that you'll see Brian Finster reference a lot as well in regards to continuous delivery. Business C costs. That's it. That's it exactly. All right. So Jez mentioned a breakdown that is basically 95% of the pipeline in HP's example was spent on meetings, planning, support, bug fixing, maintenance, manual testing, right? And then when you added it all up, only 5% of the time was spent actually writing new features. All right, so if you put $1 million into a cycle, whatever that is, a month, a quarter, a year, that team only invests $50K into deliberate feature production. Everything else is either a waste or accidental. Right, so the features do get produced, but they get produced accidentally, unplanned, by testing, by support, by bugs being reported way too late, by manual testing having been done way too often manually, repeatedly. People start skipping them because they take too long. By planning, by meetings, things go wrong. You need another meeting, right? So once you're on the wrong side of this equation, you're very much at the risk of going even further downhill. Right? So that's correct. Who is this? It's one of the Thomases, isn't it? Hey, Thomas. Let me refresh real quick. Yeah, it is Thomas. Hey, Thomas. Right, so the business sees costs, but the costs might not be obvious because the business always requires a simplified view of what's going on. Right, so it's very difficult for me to say to somebody, hey, okay, we're on this new project, especially an internal team. We're on this new project. Everybody's coding 8 hours per day on the new project. If we start doing TDD, it's going to be 7 hours per day because the other hour we're doing tests. Okay, so you're 13% less focused, less efficient, the business might say. How do I know that I get that amount back, right? So how do I know that the remaining 87% of your effort is now somehow worth more than what I perceive to have been getting for 100%, but in reality, it's the 5%. Right? So it's this inability to separate out real data from intuition, where a lot of sort of engineering to business conversations fall short. Right? Because you need to be able to present to the company the harsh reality that if you're not doing TDD or anything equivalent, right? So any deliberate practice that is documented, that I can see on your calendar, like today, I'm doing TDD pairing with this person. That is a calendar activity that I, as an outsider, can look at and say, okay, so that's when the quality happens. If that's not on the calendar, if that's nowhere near on people's agenda, on people's reports, on people's sort of one-on-ones being mentioned, then I will be very concerned as an outside observer, as a coach. Of course, I'm biased. I work with these companies mostly, so I see this all the time. That's not to say that this is the most common case that happens, but it is worth knowing how to get out of this. So it's this inability to sort of build a bridge, right? So the business sees costs, and the business sees the costs of engineering as a black box. They might have a breakdown of, okay, how much time was spent on features, how much time was spent on maintenance, whatever that means, how much time was spent on infrastructure or DevOps, and how much time was spent on keeping the lights on activities, right? Keeping the lights on activities might be security, regulation, new features that are basically just masquerading breaking changes from third-party APIs or updating some package JSON, because you have some kind of certificate or a security mandate, and you cannot use end-of-life software, right? So the maintenance plus keeping the lights on activities require you to do things like bump your version, you need a backup of your cloud provider's RDS instance for Postgres, but they dropped support for quick restoration for this version, so you need to upgrade your Postgres SQL version, which means you need to upgrade your driver version, which means you need to upgrade your API version because there might be some breaking change in there, there's some coupling in there, right? So usually these things trickle down inside the infrastructure, and that's usually a mix of keeping the lights on activities and maintenance. So to really build a bridge and to have a meaningful adult mature conversation where nobody freaks out, what's most important is to stay calm. Is to stay calm and say, look, all the features that you want, we've been producing with only 5% of your budget. To use Jess's example here, right? So, but that 5% of activity is enabled by all of the 95% surrounding things, right? So when we say, I want to do TDD, I'm not taking away from that 5% budget. You're not going to get less features. That means that I, as an engineering lead, let's say, I am taking away speculatively, because obviously I don't know what the ratio will be going forward, just a forecast. I am speculatively taking away from that manual testing and support budget and putting it into TDD, very much adjacent to that feature building. And you cannot have this conversation earnestly if they, the business, think that right now the amount of effort and focus and budget you're placing into the requested features, which are communicated as the most urgent thing, if they think you're doing 100% right now, right? Because that's hard. It's a hard conversation. If they think, if you're ashamed to admit that you're not doing 100% right now, actually, we're nowhere near that. We're going so slow. 2% of the budget is invested into features, which is why we need to cut scope, cut features, really focus on one thing. Startups are notorious for making this mistake. They want to do 10, 15 parallel tracks. I opened the roadmap of a startup. It's an Excel spreadsheet, and it has 15, it's a Gantt chart. And there are ideally, a bunch of individual tracks that when things don't go according to plan, it's 15 parallel things moving, without orchestration towards the right, and everything is just being pushed and lagged towards the right, towards the right on the calendar, right? Right, so Jeff mentions not doing TDD delays costs. Okay. I'm not sure I got that. By dumping the costs in the 95% maintenance budget and increases the cost. Oh, this is hard to wait. I need to think about this one. Not doing, okay, so if I'm not doing TDD, okay, thank you. So if I skip TDD, by dumping the costs into the maintenance budget, I'm increasing the cost of the project. That's largely why there's barely 5% left or 2% to add new features needed by the business. Yeah, that's right. Because you're thinking, the business might naively think that we can collectively get away with saying, let's put 100% of our attention towards building new features, and things won't go according to plan. So whatever the final number will be, let's say it's 85%, that's fine, and we'll continue from there. Right? So if the plan was in 3 months, we want cumulatively 300% of what is possible in a month, even if we're 85, that's still 255% of what is possible in a month. But when you're actually only 5%, then once they invest 300% of a month's cost, they only get 15%. out. That's the scary bit. You know, if these numbers are 1 million and 50K, they expect for 3 million investment to get a rocket ship, and what they get is like, you know, the tip. They get the waiter's tip. And that's what the entire production system was built on. And then it is being maintained on the actual budget. Right? So it's Kent Beck mentions it slightly with optionality, but that's more forward thinking. I think if you want to really have a mature, leadership-oriented conversation, you need to look at it. You need to be able to critically assess your history and say, we invested this much into feature development, and now, today, we have tasks in the pipeline which are consequences of our decisions 4 months ago. Then it's really important that the people in the room have enough, I wouldn't say foresight, but just common sense. Common sense is sadly not common generally, even though you might think so. So what's common sense to me is not common sense to you, which is funny. So you would basically want the entire organization to be data driven and to agree on what the data says. And that's the hard part. Because you might say, yeah, but that was 3 months ago. Now we're not doing that project anymore. Yes, but we still need to maintain it. Right? Like I'm still developing that project by virtue of receiving support tickets that mention about defects or potential improvements that the business actually mentions that, hey, actually, that's a good idea. We can make more money if we implement that. Let's do that. But also, can we have this new feature? So that's the hidden cost here, because on paper, it appears positive. But the problem is not to stop these activities. The problem is that this activity is extremely wasteful. It's too slow. You know, the longer the feedback delay, the more you'll pay for the feature. It doesn't actually have to do with how long the project takes on the timeline, and then you doing some like weird magic of like, you know, even I made the mistake of using that graph, you know, that everybody criticizes, that, you know, how, you know, write the test before implementation is really cheap, and then, you know, then integration time and review time and merge time, deployment time, and then the customer finds it, and then later on the customer finds it while the original team is gone, right? And then it's like 100x or 800x of the cost. And so it has a sort of logarithmic scale to it initially, but that research has been debunked. But still, you can find it in the Google SWE book, the software engineering guide. I think if you Google SWE book, you'll find it, and they have exactly sort of the same idea. Is that, and it doesn't have to do anything with testing really. What it has to do with is that how long are you waiting to get feedback, and that's really what it is about for the business. If we build something for 100% of the budget, and we don't understand what these ratios are, if we then end up, okay, hang on. Oh, that's a good question, Thomas, the other Thomas. So let me just finish my thought. Otherwise, I end up rambling accidentally. So if you end up building a feature for 100% of the budget without understanding what those ratios are, without understanding really how much goes into the system, you're more inclined to entrain and to sort of create a bias for your non-technical people to think that, oh, most of the budget is spent writing code, you know, like putting code into the machine, and then we just debug it and we do QA. And that's not how quality happens. That's how you get those really expensive band-aids on a badly designed system. And a lot of people don't see an alternative to this. A lot of engineering orgs that I talk to, they do not see an alternative to this. They think that it's normal to build software like this. And to me, the only way to get out of this mindset, because I was in it as well, I worked in organizations like this, is to adopt TDD, but not adopt TDD only in the sense that I'm doing TDD as an engineer, as a craft, and I wish Adrian was here because he wanted to rant with me about engineering versus craftsmanship. I hope we get to do that. So Adrian, if you're watching, I'm excited about that. Right, so this idea that yes, I can do TDD alone, and that's already going to be helpful. But it's even more helpful if I'm pairing with the team while I'm doing that, or if I'm assembling with the team while I'm doing that. And it's even much more helpful if every now and then I have somebody non-technical pairing with me to really check my vocabulary. Does this make sense to you? And to really be able to share a common language to say, hey, I'm writing a test. I'm expecting the user to behave this and this that way. Does that make sense to you? Without going into details like functions and classes, or which methods are private or public. We had a discussion about that today on LinkedIn. And what the classes look like. What do they extend? How does it get loaded in the database? That might be important for like business analysis and, how will this look like in Power BI 3 months from now? That might be an interesting conversation, but you should ideally have separate models for that. But I digress. I don't want to go into that too much right now. Thomas, why do we talk about software development separately from the cost of testing? For example, no one asked Grassman how much it costs if he takes a hammer and another tool with him. Don't questions like these show that we developers are afraid of TDD? That's a fair point. Okay, I have a follow-up. What I mean by this is that testing, TDD, Thomas says, has something to do with quality and the sustainability and stability of my code, and thus benefits the team and the product. Well, that's the point. So I was using an example from Jez and the cost, right? So when we talk about costs, I mean salaries, right? So the primary cost on a software project is going to be, your SaaS operational cost, your infrastructure costs, plus the salaries of the developers. And ideally, what you would want is you would want to have a setup where each developer that you hire exponentially leverages how much revenue you get out of every basically investment into the team, OpEx on the team side on salaries, and or the infrastructure, depending on which one's higher. There are teams where the infrastructure cost is very high, especially for data-driven organizations. Yeah, I can hear Gaia screaming at the top of her lungs. She has a bit of a cold, and that one I can tell. That's the nasal aspirator pulling out snot from her nose. She's gonna be fine. They're doing great. They started walking a few weeks ago, and they've been penguining around the entire apartment. It's so wholesome. Okay, but let's focus on this idea that Thomas is mentioning about cost. So I think, the business side I don't think the business side really wants to talk about quality and sustainability. For them, it's implicit that it's very high, right? So if I'm paying you a lot of money, I expect your work to be of high quality, especially if I'm non-technical. Right? So I'm not paying you a lot of money to then tell you, please don't do TDD. Your business stakeholders might ask you not to do TDD if they question your competence and they think, or they might see they might hope that if they influence you not to do TDD, that they'll get their features faster because the deadline would actually prevent them from wanting to continue with some kind of initiative. Right? So it's possible that the business stakeholders, the CEO, let's say, or the product owner, actually is very much realistic with their own gut feeling of, you know what, if it takes more than 3 months, I'll cancel the project. So they know that is the constraint that they operate under, and they aren't sort of holistically involved with the overall cost of, of course this will take, of course, once you build a feature, we will have to maintain it for 10 years. Of course, for you as a software engineer, that makes perfect sense, right? So if I create 10,000 lines of code for a silly feature that nobody cares about, if I leave it in the code base and the company survives for 10 years, somebody will need to maintain that. If nothing else, somebody will need to, poke at it every now and then to check if it still works. And once a year or so, somebody will have to sort of penetration test it to see if that feature that nobody really understands, does it cause any security concerns or privacy concerns or performance concerns? Does it log way too much, and then our Datadog costs are way too high, right? So that's the idea here. Their expectation of quality is implicit, and only when you lose stakeholder trust do they start this sort of fiddling thing. It's like, hey, like, your work is promised to be here at high quality, and it's not really here. If I don't really get quality, if I ask you not to do quality, do I get the same thing but faster? Like, that's what's going on in their mind, right? And you have entrained them, you hypothetically, right? If you end up in that situation, they are having this conversation with you because you or somebody in your organization representing you, who was in your chair prior to you, has entrained them and incentivized them to have such a conversation with you, to try to help you to make the deadline. Because they obviously care about that, because they set the deadline. Again, estimations on a different episode. I hear you. We had a lot of requests yesterday on the after show about talking about estimations and really how to have these negotiations. So deadlines, estimations, some other episode. Thomas, yes, follow up. Exactly, and that's why I don't have to look at the cost of testing in isolation. It's part of it. The product is a complete work, and part of my job is testing. That doesn't interest anyone except the team and the owners. And in the end, it's a win-win for the team and the product, i.e. my backers. Yeah, that's exactly it. And that's even a precondition for, I have the book, Planning Extreme Programming here, which is Martin Fowler, Kent Beck. This is one of the older books, by the way. So, but if you've read any of the Scrum books, you can, it's basically the same thing. It's not, it's an older book. Okay. So it's not, it didn't fascinate me as much, and it didn't inspire me as much as the more recent books, especially the more recent blog post by Martin Fowler and Kent's new newsletter. But there's this interesting concept in here, which is called the Bill of Rights. And I just want to show it to you, right? So it's page 9. It's at the very beginning of the book. It's Bill of Rights, and has a customer Bill of Rights. Customer here being a analogy for stakeholders, right? So somebody who is responsible for the project. The customer being who is buying the software, not who is using the software. So the customer is not the end user. The customer is the person responsible for the software to be operated, which, for the example that I mentioned earlier, is your CEO, is your business people. And then there's a programmer Bill of Rights, right? And it's very clear, right? In the programmer Bill of Rights, like, you have the right to produce quality work at all times. Right? So the precondition to do extreme programming well, and by extension, continuous delivery, truck-based development, pair programming, TDD, lean, and all the sort of accompanying adjacent practices, that you have the right to produce quality work at all times, so it'll never be questioned, and you have the right to make and update your own estimates. That's a deadline thing. And you have the right to accept your responsibilities instead of having them assigned to you. Right? That's interesting. Right? So in an ideal world, if you want this equation to function, you, the engineer, the craftsperson, need to decide what the right level of quality is. Right? So it shouldn't be something, it shouldn't be a list item on the invoice that says, did we include tests or not? Did we do TDD or not? Right? So it should never be negotiable. It should be dynamic. It should be malleable. Like, you should be adapting the process to the problem if it needs to be adapted. And then it should be packaged together as part of the process, part of the solution. But looking at it separately from this idea that we can build features and then we'll negotiate whether to do TDD or not, that doesn't make sense. Because obviously somebody who doesn't understand, if they carry high influence, if they carry a lot of authority, or just have a strong voice, a strong opinion, just by being, the CEO or the founder or somebody who carries a lot of weight in these sort of political weight in these conversations, if you show them this separation, they won't understand it, and they might actually make the wrong decision here. They might ask you, hey, why is it separate? Does it make sense to not do TDD? That's what a benevolent leader might ask. It's like, hey, I don't actually understand why it's separate. If we remove it, does it go faster? And even the question is tricky, because you might be inclined to say, well, yeah, it's faster now, but then it will slow down, and then it will be more expensive later. And for a lot of stakeholders, that's actually a trade-off that they're willing to make. A lot of investors will say, oh yeah, like I would rather have cash flow now. Like when you tell me technical debt and TDD, it's like, yeah, like I want cash flow now, and then I get the money immediately, and then I can invest a little bit more a little bit later. And in business terms, that is always a good decision. It's just that we mistakenly present the option to do this as a good option. Because usually we don't know how they operate. Usually we don't know how they think. That's why it's so dangerous, right? Because we cause this. We cause this behavior, us developers, right? When's the last time you sat down with one of your colleagues, one of your peers, one of your friends, one of your buddies, co-workers, an external team that you have to pair with or have a meeting with, and you say, oh yeah, like I wish we wrote tests, but we don't have a lot of time. Like we're in a rush, right? What's happening here? Developers are communicating that if I skip tests, it will be faster. Which means you don't really understand the point of testing. Because the point of testing is to speed you up. To speed you up, to communicate intent, to increase the quality of the software, to increase the safety of the software, right? So, our industry, we call ourselves engineers, but we're not licensed engineers, right? So if you're a nuclear physicist, if you're a nuclear engineer, you need to be a licensed nuclear engineer to be taken seriously. Why? Because you might understand the craft, but the license tells your client, your customers, that you are doing your craft in a safe and responsible way that is safe to the community. And that's sort of the idea with TDD, is that not only am I producing features, but I'm producing features in a way that is safe for the business. Because otherwise I'm doing risky shit. And it's like taking the safety off on every technical decision if you're not doing TDD. I might skip this, I might skip, it's like getting everybody, here's all the corners we can cut. And the business just says, okay, time stress, select all, uncheck all, ship it, right? And that's the worst way of building software, because it will always come back. All of those checkboxes that you unchecked, most of them will be benign, and a few of them will explode. The problem is you don't know which, right? So none of them are safe to uncheck unless you deliberately have measured the potential consequences, if you forecast the consequences. There's an interesting discussion going on here in chat. Let me. Thank you for being so active in chat, by the way. I do love a little bit of back and forth. Wait, so Thomas, you had 3 comments. And then it was Jeff. I've seen IT and above leadership try to push testing off on separate low-cost dedicated testers as it's cheaper, and they believe the result will be similar. And exactly, this is exactly that problem, right? I've had the CEO and the head of QA come to me and demand. Oh wait, it's a cut-off comment. I had the CEO and head of QA come to me and demand that I and my team stop doing developer testing, not even TDD. They demanded that developers completely stop doing any testing at all. QA has taken complete responsibility for all testing. They said that company did go out of business primarily due to the excess of severe bugs, none of which QA could find. And that is exactly this. This problem was caused by engineering. not by the CEO, not by QA. This problem is caused by us, right? If you're a Star Trek fan, it's the yellow uniforms or the blue uniforms. You know, like we're a mix of science and yellow uniform, like blue and yellow. Okay, whatever. Right? So it's not the red shirts that caused this problem, because it's us that fails to communicate that moving these things to QA is a bad idea. Because QA testers and people generally who click workflows in Cypress spreadsheets and Jira and then report back, they're cheap. Of course, because they're doing boring menial work, manual labor. But they can only inspect the absence of quality. They can't build it into the system. Only the engineering team can build the quality into the system. And ideally, it should be built into the system before it's being inspected. Right? That's the point with TDD, right? So I'm forcing myself to build the quality into the system so that I prove to my business that the way that I'm working is safe, so that the thing, when I push it to QA, there's a high chance that nothing important was missed. If I follow through on what Jeff suggested, if I recreate the scenario, what happens here? So you no longer test. What happens? What happens? Why did this business go out of? Let's speculate, right? Why did this happen? I am absolved of all responsibility to test. I, the engineer, that's the head of engineering. I am now head of engineering. I have 25 people, 5 team leads. Maybe there's 2 architects in there and a few front-end engineers. What happens? Everybody on my team stops testing. They're like, push, pipeline. And what happens? We create a lot of undeployed features. Lean calls that inventory. How valuable is inventory? 0. Why? Because it's not in production. It's not being used by a user, right? So you have a bottleneck, and Scrum to some degree is sort of aimed at fixing this. You have a bottleneck in your system. You say, oh, developers, when I invest 100% into developers, only 5% is spent on new features and 95% is spent on support and bug fixing and maintenance. Okay, obvious solution, we yoink it out and put it into a different department. What happens? More of the budget gets in parallel pushed into developing new features, but the constraint of the system, the degree to which you can provide quality and test your features, is the same. So the clog, right, the dirty bits in your pipeline are still the same. But now the pressure is 3 times higher if the CEO was actually successful and speeded up development. It's just that the problem is actually lower down the pipeline. The problem is with whoever is testing. And ideally, that should be the engineers. So if you absolve the engineers of the responsibility to test, well, guess what? They will speed up. The amount of testing will remain the same, but now you have 3 times, whatever the speed up was, 5x, 10x, you now have more things to test, and now QA is swamped. And then you say, okay, but we can have more of them. We can have more QA testers per unit of salary than engineers. So we'll make that up. And what happens? The engineers, the feedback cycle gets longer. So not only are they moving faster, but the amount of cycles they do before they get feedback also increases. So you start seeing a power law curve, right? So not only we're moving faster, but we send you 2 months worth of work, not 1 month's worth of work. And then you test it. And then we get this giant list of reports from QA telling us that this is bugged, and 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 this is bugged. In the meantime, developers are already like 3 months ahead on the schedule. Nothing's deployed. And what happens? The business sees, okay, good. QA caught a lot of bugs. I'm glad they did. I'm glad. Yes, this is not production ready. Okay. But now there's too much to fix. So we need to have a meeting. And now whatever QA produced becomes its own backlog. And somebody needs to prioritize it. And somebody now needs to decide, okay, which bugs are we fixing? Which bugs are we not fixing? Which bugs are critical to fix before the launch? Oh my God, the amount of times I've heard that statement said, like, which bugs are critical to fix before the launch? It's like, why did we create a feature that we're not prepared to deploy in a buggy state and then have a conversation about which ones are we going to fix and which ones are, it never made contact with the user yet. It doesn't even work. You don't even know if the specifications were correct. Never mind us now doing like this second or third degree backlog shenanigans. Like, that's where the problems happen. And the way you get out of that is for somebody in the engineering, you take responsibility and say, hey guys, look, our investment plan doesn't make sense. Right now, we made the speed at which we produce useless inventory faster, so we're burning budget faster, and we've made our feedback cycle longer, which is bad, and we decreased the rate at which tests are being written and feedback is being acted on and bugs are being fixed. And now we need to, because you have extra meetings and more people to manage, right, with the testers and the cross-department communication. That doesn't make sense. What's the solution? This was a fun experiment. Let's undo it. Let's focus QA primarily on exploratory, like penetration testing, like trying to break it in new creative ways, and regression. And developers, please start doing TDD. Right, so the solution is the opposite. That's why we're having this conversation, right? Because from a gut feel, what Jeff here has demonstrated, what Jeff here has mentioned as an example. Well, it's not an example. This actually happened for Jeff, I assume, right? It's very intuitive for the business to make the decision. But they make the decision without understanding the underlying cost-benefit ratio of testing itself. Testing needs to happen very early, like frequently and early in the pipeline. That's the most important ingredient. Not because the more frequent it is, the earlier it is, the higher your, in car terminology, you're in a higher gear, right? So your torque to power distribution is much higher if you do it early on in the cycle. Otherwise, you'll just have to rev up the engine and go really, really slowly. It's like, and then you put in a lot of power to really get a lot of control, but things are not going. Things are not going anywhere. Great example, Jeff. Thank you for having my back. Grant. Quality will always require tests. Tests are most valuable when your code is changing, and it changes most when you write it. You could argue testing code that is complete is almost wasted effort because it's no longer changing. This is in my post, and it's in the book that I'm writing. So that's the announcement for today. I think now it's time to start talking about that. Oh no, it did the thing. One moment. Doop. Focus. Yes, we got focus. Nice. So the thing is, I keep talking about this in the context of critical user journey and optionality. Optionality is a term that I got from Kent Beck from his recent book, Tidy First. Huge hit, by the way, in the book club last month. In that, you want to sort of understand where your business is headed, right? So you want to be able to predict which parts of your business will be changing, right? So where do you want plasticity? Where do you predict chaos? Where do you predict changes being made to the spec, changes being made to the backlog, changes being made to features, changes being made to the design, changes being made to the user experience, changes being made to the database? And then if those areas are not test covered, you want to preempt it and start test covering it and refactoring it. So that right now we know, okay, next month we're focusing on that. I want to prepare the stage for that. If I have a really intense boxing match, I don't just go in cold. I start preparing for it. And I start preparing for that style. I start preparing for that weight category. I start preparing for that, intensity or length, or is it inside, outside? What kind of terrain is it? Right. So it's not trivial. You need to sort of take the lay of the land and say, okay, we need a process adjustment for the next project. It's end of February now. in March and until middle of April, at least that's what we think, we'll be focusing on that other area of the system. And it's a bit neglected. Okay, so today we start discovering that and refactoring it, etc. Right, so I wouldn't equate this with changes. You're right in saying you could argue testing code that is complete is almost wasted effort. It's not wasted effort in the sense that if you could predict that you could make changes to it, that doesn't mean that you will. It just means that you have a hunch that you will, and you might end up not doing it. So even if you thought that you would do changes to it and that's why you discovered it, even that prediction might have been wasted. But in that same vein, you could have predicted that we won't be making changes to it, so you don't discover it, and then you end up having to make changes to it. Right? So it's a lose-lose situation. Right? So you can't get it right. So the best thing you can do is to minimize the intensity, the shock to the team, by just having everything sort of baseline test covered. And that's what TDD provides. It's like if we have to make changes to any part of the system, let's just have a baseline testing strategy. So that even if we have to increase intensity of testing, or even better, decrease intensity of testing, because we're really sure, hey, you know what, let's feature freeze this part here. We're being some new regulation is coming in. From now on, we need to feature freeze this thing. The code base, casinos have this, banks have this. From now on, this part here has to be frozen. Okay, you can sort of lower the investment and testing on that if it's already adequate. Then you can speed up on some other area and discover that a little bit more, even though this one is being actively used. Right, so the idea here is not that your stakeholders will want to tell you, hey, don't test, and there's a cost to testing. No, the issue is that you want to be able to adapt where the seams of change are being predicted, architecturally speaking, and that's very hard to do. So somebody needs to be a very good poker player. Right, so your engineering team in the stakeholder meeting needs to be a very good poker player, needs to be a very good negotiator. It's like, yeah, like chance of success is low, but that doesn't mean all decisions are bad. If there's a 10% chance, I used this example yesterday on predicting the weather in the after show, right? So forecasting the weather, there's a 75% chance that tomorrow's weather is going to be the same as today. That's sort of average, right? 75%. And this is now made up, right? But imagine that. Let's take it for granted. If I have a machine that forecasts the weather, it has to be better than the confidence compared to the confidence that I get from looking out the window. So it has to be better than 75%. So if the machine gets the weather right 50% of the time, it's wasted. It's fully wasted because I can get better confidence by just looking out the window for my area. And that's the same thing with no estimates, and why no estimates is so popular. It's not that estimates are harmful, right? It's just that no estimates happens to fall into the same category of accuracy as estimation. So they're the same. That doesn't mean that estimation is harmful. Estimation is just as harmful as not estimating. But then you have a choice to make. Like, do I want to do the thing and have no consequences, or do I not want to do the thing and have no consequences? Right? And, I would prefer not doing the thing and doing something else instead. Now, is that other thing more harmful? I don't know. Right? It depends what you replace it with. Right? But your baseline for accuracy is important. If the chance of success is 2%, if you can get something in the pipeline, some process that guarantees 2.5%, that's huge, right? Because it increases your chance of success by, relatively speaking, by 25%. That's amazing. And that's how we should be thinking about testing. It's like, no, I know that we probably won't change it, but if we do change it, we can lose a fuck ton of time. So I'm gonna sort of go out on a limb here and discover this. While I'm writing it, because that's when it's cheapest. And that's the game here, right? And then you say, okay, I will do this by default, and then only in extreme circumstances that I will take responsibility for, I will make the decision if I should skip that process or not. Never the business, right? So the extreme programming in the Bill of Rights is very clear. Business people make business decisions, so they say when the deadline is, and technical people make technical decisions. So they say what the deadline is, they say what the budget is, and I say what the estimate is, and I say what the level of quality is. Because obviously they expect it to be on time and to be high quality, and I expect it to be, according to my best practices and according to my levels of pressure, intensity, and well-being inside the team. That's the point. These two things have to work together, and the business people and the engineering team need to see themselves as peers who are mature, benevolent collaborators in a very complex system. Not complicated. There aren't millions of people involved. That would be complicated, like governing millions of people. Google has that problem. Google has more engineers than a small country has people. That's complicated. But you're just in a complex system. You change a few things and you ask for a few features, and that's chaos. That's complexity. Yeah, Thomas, thank you. So Grant mentioned, quality will always require tests. I would say quality, what quality requires is early feedback. It's the same thing with my book, right? I'm writing a book now. I noticed I don't have enough feedback, so I'm changing my strategy. Right? Because I can say, I can write tests, I can put in quality, I can write software, I can write tests until I'm blue in the face. But the important part is feedback. Right? So I'm writing a test to get feedback from the system, feedback from the compiler, feedback from the past me that understood the problem, or from some other engineer that understood the problem. That's the point, right? That's what a test is. It is the codification of somebody's English skill to say, hey, I think the system should be doing this. That's the idea here, right? And then to get feedback on it, is it doing it? Is it still doing it? Was it not doing it? Now it's suddenly doing it. Did you do something right accidentally? Even if it's by accident. Sorry. Focus. I need to fix that. And then in the other direction as well. Did it used to work and now it no longer works? Okay, well, what's the bug? If I wasn't the author and if I didn't willingly break it, how much information do I need to figure out what's wrong and how to fix it? That's what tests are for, right? Because things will accidentally break. 10 people, 15 people can form 1,000 combinations of communication flows. Only 15 people, right? So 15 people have, if they're interchangeable, if you change up the variations a little bit, I think it comes down to, with rows and EMs, to 700, 800 connections, right? So the point is that even with a few moving parts in a non-complicated, in a simple system, the complexity of just how many different configurations I can end up in, how many different messes I can end up with, is very high. So you want to be able, you want to fix the problem between 2 people, 3 people, right? You don't want the entire system to be tested outside in constantly, and then the system has 10,000 permutations. Because if you miss one of them, not only do you then question, hey, okay, is this correct now? But also, okay, what permutation is this? What does this permutation mean? But if all the other tests pass and this one doesn't, how is this permutation different? It doesn't seem connected. There's some weird action at a distance thing going on here. That's what you want. The testing, the unit, TDD specifically, helps you constrain beyond Dunbar number. So you go from 23, 25, 50, you scale it down to 10, you scale it down to 3, you scale it then down to 2 people. You, the past you, talking to each other from test to implementation, and maybe one more person pairing with you or reviewing your code. And then the quality stops here. These 2 people guarantee quality. It doesn't have to go through this weird limbo, the circus of, I will approve it, and then somebody will merge it, and then somebody will deploy it into staging, and then a 4th person will QA it, and then A seventh person is managing how things are QA'd because we have less instances than testers and more branches than we have instances. And then there's this like weird circus going on, and that's where the waste happens. The things still need to be done. Remember, when there's a bottleneck in the pipeline, the bottleneck remains the same size. You just moved it, right? You just moved it further away from where the problem originated, right? But you can increase the pressure in the pipe, but water won't flow through faster. You need to unclog the pipe. So every time this is happening, you need to teach your business or your product people how to look at the entire flow of the system and say, you know what, we have a constraint. Like we need to do something that addresses the constraint. Okay, so if you, let's say Jeff's example, CEO says, let's do QA. One of my mentees recently, 2 weeks ago, they had exactly the same situation and they were extremely frustrated. CEO wants to do QA, I don't know, developers in Pakistan or some Philippines, because we're going too slow and it will speed us up. And they were frustrated and they couldn't articulate why, right? And we had exactly this session in private, which is also what inspired me to have this conversation with you now, is that this conversation is primarily about, okay, what's the constraint? Where is the flow of the pipeline clogged? Here. We don't act on testing feedback fast enough. Okay, so if we introduce QA, does it make it faster or slower? And if you think about it for 5 seconds or try it, you don't even need to think about it. Just try it. Try it for a week. Then check. Is it faster now or slower? If it's a lot faster, all the power to you. My gut feeling says it won't be faster. But if it's faster, go for it. You might have stumbled on something unique that works very well in your organization. Or you have a lot of seasoned engineers in your QA team, and they're actually fixing bugs. That's going to happen. But I would wager what happens is that you figure out that, hey, actually we slowed down. Okay, so undo that decision. Undo that decision. That's really important. Don't try to fix it. Your process either works or it needs to be replaced. There is no fixing process. You need to replace it with something else, which means do something that you've added and then add something else. What a lot of business owners get wrong is that they add a process, and then it makes one metric go up and then the rest of them go down. And they just keep adding process onto all those little things until the entire organization is just suffocated with rules and nobody can do anything anymore. And then that stability, that the suffocation provides, gives this illusion that, oh, things are stable now. No, it's just nobody's able to make decisions anymore. And it happens more often than you might think, right? So you got to go with this sort of Elon Musk approach. I don't agree face to face with Elon on everything, but this approach of just remove processes. You find your roadmap wasn't accurate. You find your deadline wasn't accurate. You find your quality isn't there. You find your engineers aren't as happy or as productive as you think you might be. Look at what process you can remove first. Remove process. Remove rituals. Remove like bullshit ceremonies. Remove Jira. Remove, I don't know, sprint planning sessions. Like 4-hour sprint planning sessions are crazy. And then add something into the vacuum that it then creates. See if some other solution will have better traction. Same thing with TDD. You got to remove something. What do we need to remove to add TDD? Well, this late testing thing. Oh, we'll test it before we deploy to production. No, we got to remove that. It has to be deployed way before we go into production, right? So the code has to be ready the day we develop it. Imagine that, right? You have a 3-month project, 2-month project, and that's 40 business days, let's say for 2 months. The feature you build on day 2 has to work on day 2. How crazy is that? Not tested on day 35 before the launch. Day 2. If you want to be on time, you have to be on time every day. That's the point with TDD. At least I hope it's getting across. Do let me know. Do let me know how this is going. We got some comments here. I just want to catch up. This is the other Thomas. So what reason should a business person have to add TDD to his business? What should the business have to see to make this decision? What should the business compare to see the output is better with TDD? And as a follow-up, what risk and what errors will happen without TDD and how to measure it? And then Jeff responded, I think they don't want to pay for testing. Saves a lot of money now, but when bugs are found, they'll sure blame you for it. So you're responsible for it. But they like to avoid paying for it. I sympathize with them. I'd want that too. But trade-offs is really save a little now at the expense of big costs soon, or potential of big costs soon, and reaping for the rest of the life of the product. Yeah, that's it exactly. Same emojis. Nice. The cost of fixing a bug, including business costs of dealing with it, rise exponentially with time. If that does not terrify you, then please reread and consider. Yeah, and that's exactly. We're on the same page. Nice. I hope the two of you are having a conversation and not Thomas with somebody that I can't see. Thomas, is there somebody else in Twitch chat that I can't see, or are you having a conversation with me and with Grant and with the comments that I put onto the and with Jeff and the other Thomas? AI to the rescue. Right, so Jeff mentions bugs. In that case, bugs corrupted data. Customers threatened to sue. Investors paid them off and find new customers. Eventually, they could not find any new customers without a business. Exactly. Right, so there's more to your system than just features. You know, if you leave your system with features half developed in a buggy state, and users show you, hey, we want to use this, but please fix the bugs. The longer you don't fix the bugs, and it will take you a very long time to fix the bugs if you're doing it if you never did tests, then the users will accumulate a lot of data that then you'll have to retroactively fix or retroactively migrate, right? So I've been in a lot of businesses when there was a bug, and every bug, if it was in production, had 4 stages. We develop it, we test it on staging, we deploy it to production, and then we have to migrate some kind of data fuck up. And it's that last thing that's really complicated. And sometimes things go wrong there, and then you repeat the cycle in a much smaller intensity every now and then. And I've stopped doing that since I was doing TDD, because I can guarantee a much higher level of quality to prevent that from happening if my requirements are good. But then I make sure my requirements are good by challenging them. Right? So this idea, and if you're event sourcing, it's another good approach of how to take technical responsibility for being able to do this. If you're event sourcing, it's very easy to check, okay, here in the data flow, this problem started happening. So everybody who has this order of events from that date onward, just reconstitute how this is calculated, add an event to say from here on it's fixed. Do not fix this person again. And then you sort of just backwards reconstitute whenever you need it in like a hot cache or a projection that you only need when the actual user that was affected actually joins the website. And then you gradually tombstone those old events out. And that's a very powerful tool to have. But with event sourcing, it's always, people ask me, should I learn event sourcing? I say no. Most engineers should not learn event sourcing. Event sourcing is for people who are extremely good at their craft. So they're already at a high level of quality. And for those who are extremely bad at it, right? Because if they're really bad at their craft, I don't want them touching production code. I would much rather they learn event sourcing, right? So I'm just limiting the amount of exposure they have to be able to create buggy software. Jeff mentions test after gatekeeping is how Detroit got hammered by Toyota and still keeps losing. Yeah, that's it. And Toyota gets this sort of by the book example of, they were doing lean and the precursor to Scrum and how well it works. But really the important aspect that made Toyota so successful is that the engineers, right? Again, the Bill of Rights, the engineers were responsible for the car. So every car had a chief engineer and some form of designer. And the chief engineer was calling all the shots on all of the engineering decisions. There was no engineering decision that was made by a non-engineer. That was the whole point. The right people solving the right problems with the right tools. And so people over processes. That's in the Agile Manifesto. But we get this confused sometimes. There's another thing I wanted to mention. Thomas asked, I want to honor your question. What reason should a business person have to add TDD to his business? None. It shouldn't be the business person's decision. And that's my point. How does it benefit them? Well, you should be measuring other business metrics and then the report. Hey, we've adopted TDD. We tried TDD. It worked here. It didn't work here. Here's why we think that happened, but it seems to show a net positive. You should report that you've tried TDD and it's having a net benefit over 6 months. That is your ideal way of communication. That's my point. The business person should never have a reason to add TDD because they can't understand it. They shouldn't be the one making this decision. It's somebody technical, somebody in engineering, the VPE, the CTO, I don't know. Then is the coach who gets brought on and gives a strong recommendation. Right? That's the point. Not, hey, I want to do TDD. Senior management needs to unanimously agree. No. Because then non-technical people are making technical decisions. Right? It's like have a committee for the nuclear power reactor, and I can have 5 nuclear physicists make the decision, or I can have a board with the head of engineering and the marketing and sales and somebody from politics. And now let's vote on whether we should add the safety valve. No, the engineers should make the decision. And then if somebody cuts the budget and they have, if the valve gets affected, that's when you have the hard conversation. Right? So the business side should maybe cut budget. Maybe they should say, well, look, we're doing TDD and you cut the budget. It's a good thing, right? We're extremely tightening the scope, right? But now if I'm responsible for engineering and you're responsible for the budget, if we have a product owner in this triangle, then they are getting squeezed, right? That's why there's that second element in this episode, in this show for today, right? It also affects product. Because if the business says, here's the budget, here's the deadline, and they have left scoping and business analysis and business requirements to the product owner and design and sort of, creating hype with marketing or some kind of, any kind of growth or product-led growth strategies. If the business and engineering agree, then product gets squeezed. And that's also a problem, right? So then you also need to involve product into this equation, right? You have the role of the customer is split into the business side of things, cash flow and operations, and then there's the user side of things, right? So that you Scrum gives power to the person who represents the interests of the user, who represents survey data, who represents observing users, usage data, interviewing users, watching them use watching recordings, trying to sift through all that data about how users are reacting to the system, brand management, and trying to translate that into technical language, or at least new requirements or new features or changes, right? Like, so if there's 3 people on this, if there's a chief engineer and chief product and a business person, now you have this like weird love triangle, and you just have to learn how to work together. There's a reason, like successful companies, like SpaceX and the AI company Synthesia, they have a VP of engineering and product. It's one person, right? Because in such a company, in a SaaS company, in an AI company, most product decisions are engineering decisions. So it should be one person's responsibility, or at least there should be one clear chief that doesn't look for quorum on the decisions. And whoever is personifying the technical side should then decide, hey, I have decided that the best thing for the business right now is to add 3D practices. And we don't know how to do that, so we'll call Dennis for coaching. Or we'll talk, or we will send everybody to, I don't know, QCon, and there will be this huge conference, and people will get inspired, and then they'll meet TDD practitioners or TDD coaches, and then they'll come back with a few references and a few books, and then the inspiration alone will carry their enthusiasm, right? And then the engineering manager or program manager or VP removes impediments. It's like, hey, okay, if we want to do TDD, we need to remove this process and introduce pairing, for example. That is how I would approach it, to answer your question, Thomas. What risks and what errors will happen without TDD and how to measure it? I mean, that's weird, right? Because you can't measure, we have a risk here because we're not doing X. You can't prove causality there. So I wouldn't phrase it that way. I would phrase it as, what is your planning accuracy? And when you have defined your quality, so if your quality requirements, let's say 0 bugs at launch, are written down, how accurately are you meeting that criteria? And then if you're really bad on those two metrics, then I would say that might be a signal that there's a quality bottleneck somewhere in the pipeline. So not doing TDD is you saying no to a very good tool that is very good at solving that kind of bottleneck. But again, it's a holistic approach. The engineers will have to change how they program, what tools they use, how they communicate, on what time of day they program, right? So a lot of engineers who don't practice TDD find a sudden shift to TDD very invasive in everything they do, and where they sit, how they program, what tools they use, when they program, who they program with, are they being watched while they're programming? The code review still makes sense. Will the pipeline start screaming at them if they don't add a test? Can they get away with adding a test later, or does it have to actually be TDD? How will people know if it's actual TDD and not like we wrote the implementation and then I reversed TDD, right? So that's the idea here, right? So you just want to do it gently and ideally empower the team. We mentioned this. AI to the rescue, Grant. You can use the Pathfinder rule. If you touch existing code and there's no test, write the test first and clean up the code. After this, add the next things. Test it first, of course. I like this. So I like this idea of leave the code in a better state than you found it. But I find that this is a bit too invasive. At least I work in very messy code bases with teams that are very smart, but they're just, they inherited a very messy code base, a legacy system that makes a lot of money, but now things slow down, right? Because of those, that budget friction that we mentioned earlier. So what I would do is I would teach them first how to refactor without tests, right? To only do structural refactoring that the compiler will catch, right? So make it easier to add the test first, clean up first, extract it, add naming, make the functions and the language resemble plain English, and then plain English in the business terminology. If they don't know business terminology, if the features do not speak plain English, they also won't know what to name the tests. So starting with the tests is the wrong side here, because the design might also be fucked up. So you don't want to be testing, if there's like a controller class, you don't want to have a controller class test, and then the controller class is this huge God object, and then the test becomes this like huge convoluted end-to-end test mess. You don't want that, right? So in a messy code base, the design and architecture might also be problematic. So that'll also be hard to test. You just want to bring it down to atomic pieces and name them in plain English. And you don't need solid principles for that. You can read Michael Feathers' book, Working Effective with Legacy Code, or Martin Fowler's book, Refactoring. I got the white edition, the sort of beige red edition, but you might know it. The reprint is black and red. It's what is it? Edison Wesley, the sort of typical. It looks the same almost as Patterns of Enterprise Application Architecture and Database Refactoring, etc. You know which book I mean. You have the book probably on your shelf. The first chapter is Martin Fowler going through some kind of theater kata. That is a very good example of that, right? So it says refactor, and you need tests constantly to make sure refactorings are safe. But he explicitly mentions a case where it's a messy code base and he needs to add a feature and it doesn't have tests. So you need to refactor first. You need to sort of suspend your, let's say, your bar for quality just to be able to decompose the problem to the degree that you can say, okay, now this is safe to operate in. Now these things can be named. Now one class doesn't do 10 different things. Now I've split it up into like 3 subclasses and a few functions, and now I can name them. And now that I can name them, I know what it does and what it doesn't do, and I'm sort of seeing I can form a sentence with this, so now I can write a test. And then you go back in and say, okay, now that I wrote that, now I see I went a little bit overboard, so I will inline back a few things so I don't have 10 functions that I didn't need. I just needed it temporarily to not have everything in my head. And now I see this is only used once and this is only used once. I'll just inline it back and name the variable that. And previously it was named, const x equals this one. And you extracted that. And then you said, oh, actually, it's only used in one place. And it's not that invasive. And now that I refactored it, now it's only 2 lines of code, and I'll add it back in. That's a natural way of doing that. And even today, I had a conversation like that about private methods. Should you test private methods? And I was like, yeah, like if you think you need to test something that's in private methods, there's probably a design problem. So make it public so you can refactor it and move it around. And then when you're done and test covered it, then decide, okay, does it have to be exposed now that it's test covered? Now that it was moved around and refactored and possibly split and merged with something else, does that thing that was private before still exist? If yes, does it still need to be private? Does it make sense to expose it? Does it make sense not to expose it? Right? And then you sort of do that, right? So you will end up with TDD opening up a few decisions and then undoing 1 or 2. And that's what a lot of people think TDD is. It's like, oh, I end up with all these abstractions and then they stay. No, you just undo them. The point is that you get to the abstractions first, and then you fix the problem and test cover it, deploy to production, show that there's value in this, that not only is this on a critical user journey, but also it's really valuable and it generates revenue for the business. And then you go and refactor it. Then you remove all the needless abstractions. Because then I just made us some money. And then, it's a no-brainer. Then you can inline a few things in 15 minutes, and just before lunch, you get to work, you make yourself a coffee, you sit down, and you just refactor something really quick while you're reading your emails. And that's the best way to go about it. But I wouldn't say the first thing you do is write a test first. That's very difficult. You need to have a very small and disciplined team to be able to safely do that in a large code base. Because it'll probably be some kind of acceptance or end-to-end test, and you might be relying on some testing infrastructure already that might be slow. So you might not actually be making the code base easier to work in. You're just sort of putting a band-aid that sort of keeps the system together. Yesterday's weather, yeah. Is that example? I've heard this example mentioned by Kevlin Henney, and I think he might have been referencing this, yeah. Thank you, Jeff. I will check that out. The old model is that quality can only be improved by doing more QA testing after the fact and rejecting and reworking more of the work. Yeah, I don't think that has ever worked. I don't think that has ever worked anywhere. QA is a means of, QA is a crash test. You take a car and you slam it into a wall to check out what goes wrong. Does something explode in a weird way? It's does it just crash, or does it explode, or are there like weird side effects? Like that's what QA is. The new agile/lean way recognizes that finding and fixing problems as early in the process as possible cuts cost and hence improves productivity. So high quality, far exceeding customer expectation is the key to high productivity. This is unintuitive to most people, but it's true. Yes, that's exactly it. And the key point here is that you stop the process, right? When you find a problem, you don't find the problem in QA, and then engineers are working on something else, and then they send the signal back, and then to not interrupt them, the engineers finish what they finished, send it to QA, and then take over what QA sent them. Because then, if these feedback loops are not in the same cadence, if this feedback loop is 2 days and this feedback loop is 1 week, then once they fix the tests, there will be something wrong with the next thing they did, and they send it back, and now it takes 4 weeks to fix. Right? If the engineer does it directly, the cost of just the keystrokes are the same, but the cognitive load, the context switching, the waiting around for just having it assigned and having the person who needs to fix it to be available. God forbid that you're assigning it. That's the waste. That's inventory. That's untested, unsatisfactory, unpublished, not deployed features lingering in your code base, not being used by a user. That's waste. What increases the productivity from a business perspective, again, is the engineers being able to say, when we find a problem, we will stop working on whatever we thought was next and fix the problem first. It's this idea of we will automate finding the problem, and if there isn't a test for a problem that we find, we will create one so that the pipeline, if you look at the pipeline as a train that goes forward, and every now and then there's a signal block and it's green, 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 green. If the team finds a problem that isn't test covered, you write a test so the next signal block becomes red. So the train stops. So that everybody on the team can go help and fix the problem. So the train isn't moving while you're fixing something really important. That's the whole point by continuous integration, is that you're constantly integrating. And it immediately lets the team know that, no, don't start building that large feature right now. This small feature that will be touching it is defective. And it needs to be fixed before we start working on that. Even though it's on the calendar, even though it's on the roadmap, even though we said we would start on Monday. We can't because it's red. We can only start on Monday if the pipeline is green from whatever work was pushed on Friday. And if it's not, then we have a good reason for that. And then that's codified. That's the point. And TDD allows you to have code in place that makes the light green or red. Now, testing after the fact, or just unit testing without TDD, also provides this, but it provides it too late. Right? It goes back into this idea of, you have 40 days to build something, and if a feature is built on day 2, you should have a green light for that feature on day 2. Or more specifically, if the feature doesn't work, the light should be green on day 2. The light should be red on day 2. That's the point with TDD. Because if you're testing after, you might build, test, build, build, test, test. Right? So if you're doing it that way and then you deploy once in a while, then the feature that you built on day 4 might only have a red light on day 17. And that by that time is a lot more expensive, right? Because now every day from day 4 onward was not on time anymore. But now you don't know how to codify that. And you don't know how to map that back into your Gantt chart, into your Excel spreadsheet. It's like, how many days are we behind? Our estimate was off. How many days are we behind now? Well, we don't know. What we know is that we have not been on track for the last 10 days, and we only found out today. And that sucks. Who wants to communicate like that? That's the point. TDD, continuous integration, trunk-based development, pairing, collaboration, right? Not Brian Finster calls this grenade-driven development, where you make a change and you throw it over the wall, hoping somebody will catch it and move it along, right? So it's this sort of handing off to QA. It's like this, it's like, I'm done. Next grenade, just keep throwing grenades over the wall, and every now and then there's an explosion. Okay, Grant, that was 26 minutes ago. I think you left already. I'm trying to keep up, but you've been very diligent with the comments. Thank you for joining me today. Jeff, with TDD done well, the code is ready to go into production whenever all the tests pass. Done well, this is every few minutes at most. With a small team, it can be multiple times a minute. Yeah, I think Stripe recently said that they deploy, they are able to deploy 900 times per day, or if you round it, 1,000 times per day, because that's how many, I would assume, that's how many commits they produce across all their teams. That's a very high bar, right? It's like 1,000 times per day. Imagine that, 1,000 times per day, right? There's 24 hours, right? So they would be deploying napkin math, 20, sorry, my brain's fried. Help. Yeah, 40 times per hour, right? So you deploy once every 2 minutes, every minute and a half. That's crazy. I mean, obviously you don't. It's even more frequent, in the main business hours. That's the whole point. Like, you want to be able to get there. But the point isn't that it's ready to go for production. The point is that everybody sees if it's not. That's more important. I can say, yeah, I added some features. Sure, it works. It's green. No, that's not the point. The point is I added some features and it was green, and now I merged it and now it's red. And now everybody sees that when I merged it, it was green and then it became red. So there was something unexpected done by that other developer that just added something as I merged as well, as I pushed the trunk. So we had a sort of side effect going on. Or maybe the data pipeline triggered something. Maybe we both added a migration that individually looked benign, but combined together it causes a problem. But at least then, both those engineers right now, or maybe 2 minutes from now, learn that, oh, actually, I can't start any new work. I can't go to that meeting because what I just did is a problem. And if I don't know how to fix it, I can at least revert it and then go to that meeting and then fix it later. That's mature. That's safe, right? So the point of licensed engineers, in that nuclear engineering example, was that, yes, you're good at your craft, but the license guarantees that you are executing on your craft in a safe and sound manner. Safe for others, right? So not only is your testing practice safe, but it is safe for the business. That's the whole point. That good engineering practices are being enforced by the engineering team. There's nothing worse than engineers complaining, yeah, like I would like to do TDD, but my manager or my boss is not technical and they don't agree, or they tried TDD once and they said it's bullshit, and that's the worst. Right? Because there's technical people who are self-censoring and not making technical decisions that they should be making. And they will end up with the blame. Quality is low, who gets the blame? And ultimately, the business is accountable, but the business leaders, the senior management are, they're under no obligation to say, oh yeah, of course I don't blame you. Or of course, we have a blameless culture here. It's all of our faults. No, but what's the issue? The issue was maybe a psychological safety problem of maybe nobody's willing to speak up anymore on TDD from the technical side because it constantly gets not shut down, not said no, but shamed or complained about it. No, but things will go really slow. I tried it before. And then there's this anecdotal sort of naysaying going on, and the self-censorship kicks in, and then everybody gives up. Right? That's why you want TDD to be an engineer. That's why I talk about craftsmanship, right? So you as an engineer should know, okay, I'm doing TDD. When I join a team, I will do TDD. If you tell me not to do TDD, I will quit and leave somewhere else. That's why I say it's craftsmanship first. You, the engineer, need to understand that this is part of your craft. You are personally responsible for this. You need to be a professional first to be able to say, no, look, I think I'm doing this for these reasons. This is what I believe. Period. That's what I'm trying to instill here. This is a collaboration with the business, obviously, because you want to help the business, then translate it into actual business metrics. What is our planning accuracy? Since we adopted TDD, that's then what I also help engineering managers and VPs measure. It's like, okay, well, obviously we will not measure TDD adoption because that's silly. We'll just look at the business metrics. And with my previous client, one of the things we decided to measure was how many extremely urgent support bugs they had to triage. And we saw a clear dip when I came in, and then I changed some processes, and I told them, hey, let's connect these two. Like, your testing practices and this constant support emergency, they're the same problem. There isn't a world where those two are disconnected. They may seem disconnected because there's a delay on the causality loop. It's lagging. But these two things are connected. So let's just measure it from the business side. It's like, yeah, if we're really good, if I'm right, then the number of bugs in support will go down drastically a few weeks from now. So we measured that. I hope I inspired you today to think about TDD and think about KPIs in these terms as well today. That was sort of my goal. And to really understand that engineering decisions are engineering decisions. You need to stand for them. because nobody else will, because nobody else understands them. You can sit here all you want and learn about TDD, but you will never get to a point where you can explain TDD to your non-technical CEO, and hopefully they will say, yeah, let's do TDD. And they're responsible. No, you are always responsible. You might tell them, hey, I was afraid to ask, but I think we should do this. And they might benevolently say, yeah, of course. It was always your decision. I never opposed it. I just want us to be on time. It's like, yeah, I think this will help. It's just you need to show the confidence when challenged. You need to be able to persevere. You need to be able to persist. You need to be able to show understanding for their situation and to say, I know, but the issue is unintuitive. Here's what I think. I think we should still do this, even though you just mentioned all those like stress about the deadlines. Here's why I believe this, and you just highlight it to them. Jeff mentions with TDD done well. Okay, that we already mentioned. Thomas, I know business don't like to buy or pay the cost of TDD, but this is the fact what they do. Otherwise, they already have it. They have to have some measurements to see that the developers doing it the wrong way. Yeah, but again, measure business KPIs, not TDD adoption. I hate SAFe for this reason. SAFe, scaled agile, has a metric for how well you're adopting SAFe. Like I sometimes coach TDD teams on like TDD and just TDD the heck out of their schedule. But I would never measure how well they're doing TDD, how often they're doing TDD. I might check in the pairing session. It's like, hey, I noticed you started implementation, you don't have a test. That is what I would say. I would pair with them and call them out on it. It's like, hey, you're not writing a test. Do you understand the problem? It's like, no, I'm exploring. Okay. That's a habit that needs to stop, right? If that means that the person giving the business requirements doesn't know how it's implemented. So there isn't any architecture. There isn't a technical spec for this, right? So you're exploring the architecture, the technical spec, the decisions while you're writing code, and that's called a spike. And ideally, you would then throw that spike away and then write a test and then write the actual implementation the second time. But usually that second and third step don't happen because a lot of engineers learn how to code that way. They don't know what's going on, so they spike, and then they keep fixing the spike. And then once it works, since it's not test covered, then they keep it, and it goes out into production. And that's the worst thing. That's the worst thing you can do to your code base, because not only is it there, but spikes are notoriously exploration driven, so they're very localized and very much, it has like a seam. It's like I can see how the developer developed it, and it can never be tested because it lacks all forms of abstraction. And people who develop in spikes, and then they keep the spikes for production, they complain the most about TDD. It's like, oh, these abstractions, that makes the code slow. No, it's like it makes you slow because you code in spikes. And if you code in spikes, you need to throw the spike away and then redo your work, which is why most people who practice TDD don't code in spikes, because then they need to have time to do it twice. But that's very unintuitive. I understand it. And I have full respect and full empathy for that situation. But a lot of engineers simply did not see a well-functioning, high-performing team. So they have no idea that their approach has a better alternative that is completely accessible to them. And it won't be judged, and it won't be shamed, and it won't be discouraged by the business. And all it takes is a little bit of inspiration, a little bit of backbone, and a little bit of negotiation skills that can be learned, right? It can be practiced. That's what I do with my coaching clients. We practice, we role-play conversations. It's like, okay, you're defensive, cool. What happens if I say this? If I'm the stakeholder and I say this, and they go, and I say, okay, chill, calm down. Notice what happened, right? So that's the thing. You just gotta practice these things, and I promise we'll have a lot more communication sessions and negotiation sessions, and definitely a session about estimations coming up. Adrian and I have to sit down on Monday and sort of plan out March. Yeah. Jeff also reiterates the business gets a number of benefits from TDD, reduce bugs, but also much better ability to fund work incrementally. Exactly. That's what Kent Beck calls optionality. It's this ability to add features. It's the ability to keep cost of change low. Martin Fowler, a long time ago, talking about tech debt, called this craft, right? This thing that just slows down everything, right? It's because the more complex your system becomes, And the more complicated it becomes, the more moving parts it adds, the higher the cost of change becomes. But your change is actually constant, and cost of change goes up. So if you ever find yourself in a situation where you suddenly have to change a lot of things at the same time, your cost of change is high, the change rate goes up, and then you just spike into this wall where everything slows down. And then you might end up, spending weeks in meetings. It's like nothing's moving, nothing's being deployed. We deployed something, it didn't work, we have to revert. And a month passes and you realize that you actually haven't moved forward. That's the worst thing that can happen to a business. Because that'll immediately bankrupt the business. Because cash flow, it immediately negates cash flow. It creates all of these structural problems. People lose hope. People think, oh my God, we're stuck. And we don't know how to get out. And we don't know how to run this in the future. And then a lot of people just end up, try to fix the problem, band-aid the problem way too late into the life cycle of a product that might last, I don't know, 2-3 years. If you should decide to do TDD, I'm assuming this is Thomas, how to decide it? How can I say as a developer, no, the TDD is good here, especially if I don't know it? Get to know it. Don't trust me for it. And what if requirements are changing? Probably all the time. Great. Requirements will be changing. Requirements changing is a sign that the business is acting on feedback. The requirements will be changing. That's a good thing. Right? So requirements will be changing. Your code will be changing. The behavior of the code will be changing. And the structure of the code will be changing. And the development time, and over time, the development pipeline will be changing. And the stakeholders will be changing. And the business organization will be changing. And the development team will be changing. So the best thing, if everything can be changed, the best thing you can do is to say, look, if the requirements didn't change, then there's this constant here, a test. And this test guarantees that requirement, if it hasn't changed, is implemented correctly. And that's it. That's TDD. That's the most important bit. Right? So yes, everything's changing, but everything that didn't change still works. And everything that did change needs to be changed. And then while you're changing it, you have guarantees that while you're changing that you're not also accidentally changing something else. That's also very important. That's TDD in a nutshell. Don't take my word for it. Try it, learn it, but don't learn it in isolation. Learn it on a business. Don't learn it in isolation and then maybe apply it on a business. No, apply it on a business. You got to learn this. You can't have the safety wheels on outside of a business in a safe environment. You have to be in a high-risk environment. If you're not trying out TDD in a high-risk environment, you're never going to learn it. You got to learn how to swim. Right? You're not going to drown. You already know how to deploy code. You already know how to negotiate. You already know how to report progress. So if you try TDD and you see, okay, I'm learning in circles, I'm stuck, stop doing it and just continue with the process. Then you report on it. I tried it, and this is what happened. Then I stopped. Then it's, what should I do next? And then that's a great question to bring to people like me, or to even just publicly. You don't even have to pay for coaching. You just mention it. I tried it. It was a high-risk environment. I actually ended up going the wrong direction, and then this and this and this happened. What would you recommend? And then next time, this is the question you have now from step 0. If you then now apply this advice, next time you'll have a better question. Next time you'll have a question where you have proven to yourself that now you understand it a little bit better. If I apply it in this way, in that context, I end up being stuck. Okay, so next time I won't do that. I will do it differently. And you're not alone. A lot of people have exactly the same problem as you're having. That's why people like me exist, and we sort of try to present it to you in a very simple manner. Okay, on the announcement side, I know we're running a bit late. Running a bit over. I just want to mention real quick that since we're closing off TDD February, it's not ready yet. That's what I'm sad about. But I've been working on a booklet that captures all of these ideas. And right now it's looking to be about 22-ish pages. My old booklet was very simple. It was just a compendium of my most catchy LinkedIn posts to sort of jog your imagination a little bit of what is possible and what are the common traps, while also taking in advice from my TDD podcast guests and have a little presentation about red-green refactor. That had some mild success, but now I really went on the deep end and really gathered a lot of research and connected even with Kent Beck and got some good feedback from them, organized a book club that did TDD, and I'm documenting everything new that I've learned and packaging it in a really bite-sized form. And I'm going to launch this in the next few weeks, the booklet. There are preview chapters available on my Substack, which is Crafting Tech Teams, and I have a banner for it. Yeah. I have a Substack on Crafting Tech Teams. If you're a paid subscriber, or if you bought the previous revision 2, which is on Gumroad, you'll get this new edition for free. So paid subscribers and previous book owners get this for free. Right now in TDD February, you can check the early chapters in TDD February for free. If you're also a paid subscriber, you also get the early previews of the chapters as I'm writing them. And as an extra bonus for you guys here who are here today, if you send me a DM, DM me booklet or TDD booklet, and if you want to give me feedback on it, I will give you an early copy, and free of charge, because you're essentially helping me. So that's my announcement for today, is that in March this is coming out. I'm polishing it, refining it. There are a lot of cool ideas here, a lot of which we've touched on today. There's going to be a little bit more code examples, a little bit less emojis, and it's structured in a way that I got inspired by Tidy First, which means the practical, really nitty-gritty sense that Thomas was asking, that's at the beginning of the book, so you can get started really quick. And then the topics about the business that Jeff mentioned and Grant mentioned and the two Thomases and the other Thomas mentioned, that's more towards the end, right? So it's TDD technicalities, then there's pair programming, a little bit of extreme programming, and then there's the business side of things that we discussed today, right? So the book will follow exactly the same format as TDD February did. And yeah, that's it. I'm still learning how to do a book launch properly, but I know that getting feedback from you guys is really important. And I got a lot of, I think I got like feedback, early readers from like 60 different people on the previous iteration, and it helped immensely. So if you're interested, DM me on any platform, LinkedIn, YouTube, Substack, they all have DMs now, and I'll send you a copy over, a sort of unedited copy when I have it formalized before it goes live. Okay, that's it from me today. I need to check on the kiddos and attend to the book club. So thank you so much for being with me here today. Sorry about the logistics problems. Adrian mentioned that there's some calendar sync issues and he got the double booked with a trip that he went on earlier than expected, I believe. I think that was the problem. He had some great stories in reserve for today, but I'm sure we'll get to it next week, because this is not the last time we talk about TDD, although we will now go into a little bit more of a platform engineering focus. Platform engineering, CI, TBD, we're not going very far. So yeah, if you want to guarantee you're not missing out on the book, subscribe on the newsletter to get whatever you can now from the free version from TDD February. DM me, or if you want a free copy of the book, buy the old one, or subscribe on the Substack. Yeah, I hope this was enjoyable for you. I had a lot of fun. I will, as always, leave you with a little bit of elevator music so that you can relax before you go on with your day. And I'll see you next week. Thank you so much. This is fun. And ciao. And that's my kids screaming in the background. It's like, that's happy screams. That's the, yeah, we're playing in the bath. There we go. Ciao.